give a nice round of applause for our first speaker. He's come all the way from England today to come speak to you. This is Cal, who's going to speak to you about SQL Pipe.
Check. Hi everyone, how's it going? I'm really excited to talk to you guys about syncing data today. My name is Cal Mitchell, and I'm the founder of a company called SQL Pipe, or SQL Pipe. I haven't decided how it's pronounced yet. And I've been building open source data movement tools since 2021. And I'm here today to show you about my newest tool, which I'm calling Remix, which is an event-driven data streaming application that I designed to increase a measurement that I call your speed of data. This tool is going to be really useful for Stripe customers who want to sync data between their Stripe database and their internal database. We're going to talk a lot about that, but first I want to define speed of data. I want to start with a sci-fi metaphor. Has anyone here, show of hands, read the book A Fire Upon the Deep by Werner Vinge? Anybody? Nobody? Okay. One of my favorite sci-fi books. It's actually pretty famous. And it has one of my favorite concepts in fiction, which is that as you get further away from the galactic core, messages transmit faster until eventually, in the beyond and the transcend, you can send messages, data, faster than the speed of light. In this universe, Earth is in the slow zone. Faster than light travel is not possible. The physics there are similar to what we know. But as you get out into the beyond and the transcend, there are godlike beings and civilizations who can do unimaginable things because their computers run faster. The neurons in their brains fire faster. However, as you go down into the unthinking depths, computers don't even work at all. You think fuzzy, and honestly, intelligent life struggles to survive. In this universe, the speed of data caps how advanced you can be. And I think the speed of data exists in our world too. And I loosely define it as how fast does critical business data propagate across your organization. So let's bring back those zones and start from the inside and work our way out. In the middle, you have giant government bureaucracies where it takes weeks sometimes to get data around them. They have paper forms. You need to send them things in the mail, etc. Moving out, you have organizations where it takes a day or two to get information in and out of their systems. A lot of small businesses are here. You need to call them, they need to check the spreadsheet, send an email, etc. Then, moving into the beyond, modern IT systems start to appear. And this is where a lot of large organizations live. They'll have some servers, some databases, some hard drives, APIs, etc. But, they might have a nightly cron job that updates everything. So you can usually get what you need in less than a day, but, it's not instantaneous. But some of these large organizations, they transcend. And we typically know the names of these companies because they're so wildly successful. I'm sure you recognize the names here. And what I find fascinating about them is that their businesses are not that innovative in terms of their business models. Well, some of them are, but not all of them. For example, Uber is just a taxi company where their speed of data is incredible. They know where the customers are, they know where the drivers are, they know what the fare should be. Amazon, they know where all the customers are, they know where all the products are, etc. I think you see where I'm going with this. And my takeaway is that even if your organization has a familiar legacy business model, if you improve your speed of data, you can actually get unbelievable results. And Remix is a tool that provides a conceptual framework and data movement capabilities to help you increase your organization's speed of data. So hopefully I've convinced you that speed of data is important and increasing it is good. The problem is that it's actually very hard. And to demonstrate that, I'm going to walk you through Remix's first supported use case, which is syncing your database with Stripe. And this is the current best practice recommended by Stripe. The first thing that I see is that there are 6 different systems here. There are 2 queues, a couple of Amazon Lambda functions that are going to need custom code to maintain, etc., an event bridge rule, a SaaS event bus. So just right off the bat, you have lots of systems, and that creates technological complexity. Next, you have to deal with typical data syncing problems, such as deduplication logic. Let's say something changes in your Stripe account because you altered something in the dashboard. It's going to send a message to your database. Now your database is going to report that something changed. It's going to send a message back, and you're going to get what's adorably called the dog chasing its tail problem. Or there's just mundane stuff, like in Stripe, the price of something is called unit amount. It's not called price. So you need to remember that forever. So here's what happens when you create a product in your Stripe dashboard and you give it a price, which you have to. Stripe will send you 2 webhook requests. They'll send you 2 HTTP requests that look something like this. But let's say you have a database table that looks like this. You can see that the structure of our data is entirely different. Stripe structures products and prices separately, and it needs to do this because lots of Stripe's customers sell products in different countries, in different currencies, so you need to have different different prices for each product. However, a very common situation is you have a database table where you just have one price. So you need to somehow figure out how to sync that. So you can see we have ID here in product and a foreign key to product and price. Does anyone have any suggestions how we might be able to get these 2 objects into one database table? Anybody? Anyone want to try? Well, these 2 things are essentially foreign keys to each other. And that will all link into the Stripe ID. So if we're smart enough, we can combine these 2 things using this unique key and update or insert in our database table. And that's exactly what Remix does. So technology is one factor that makes syncing data hard, but actually it's not the hardest to overcome. I think actually the hardest thing, especially in an enterprise environment, is more the process and the business change rather than the technology. So I designed Remix to be very easy to use and also make it free, open source, and standalone. So there's no licensing issues, of course no cost issues, and it's standalone, so you just need 1 tool instead of 6. Now the next thing that makes it easier to increase your speed of data is that it forces you to create canonical data models. Does anyone here know what a canonical data model is? Can anyone define it? Anybody? Come on guys, give me something. I know someone here knows what a canonical data model is. Okay. A canonical data model is one single way that your organization views a certain object. So you might say, whenever I have an object in my programming language that's a product, it should have these fields that are named this, and they should have these types. And Remix is very opinionated in that it forces you to define these canonical data models, which is good because then you can rely on the fact that this object is going to have these fields and these data types, etc. And a side benefit of creating those models is you then, by nature, have a very clean data set, which is very beneficial for creating an AI training data set. The way it forces you to define those models is JSON schema. JSON schema is the most popular, most widely supported way to create a canonical data model, or at least to validate that something matches a certain shape. So here you can see we're creating a product canonical data model. And our business's view of a product is that it should have an ID, it should have a Stripe ID, a name, and a price. And this is very similar, but not identical to the database table that I showed you before. And that's key. Your canonical data model is probably not going to match every single data system in your tech stack. You might have a database from 1998. I've seen them. And there's no way that those people had the foresight to call their price of their product unit amount, because Stripe calls that in 20 years in the future. So it's important that you create these canonical data models, but also that you can transform to and from other systems into that model. So how does it work? Well, it starts by listening for data changes. Change data capture from databases, which is how databases report data changes to us in real time, and webhooks from Stripe. When it gets inbound data, it then transforms or remixes the data so that it fits into a canonical data model. Once those objects are validated, once I know, hey, this is a valid product object, it then puts it into a queue. And then according to a rate limit, it takes objects out of the queue and then syncs them back to the other systems. But first, it does have to remix them on the way out the door. So for example, it needs to generate an update statement for Postgres, or to generate an API call to Stripe. So the key thing is it remixes data on the way in to fit into a canonical data model, and then it remixes them on the way out to fit into the target systems. This is the most important slide, and also the hardest to understand in the entire deck. But this is what Remix does when it receives data. On the left, you can see the two objects that Stripe sends to us if we create a product in the web UI. It creates a Stripe price object, and it creates a Stripe product object. And we need that to fit in our canonical data model. So here you can see unit amount, that's what Stripe calls price. We need to rename unit amount to price and fit that into our price field. We need to take the ID from the Stripe product object and the product field from the Stripe price, which are the same thing, and we need to coerce that or marshal that into Stripe ID, because that's what we call it in our business. Name doesn't need to be renamed. There will be time for questions at the end. We'll definitely come back to this, but first, I just want to show you the product working. Demo time. Oh, bless me, demo gods. So I move this to the right. Yes. Oh, this is gonna be tough looking behind me. Okay. So what I'm going to be demonstrating, I'm going to create a Postgres database locally, and I'm going to sync data using Remix to my Stripe account. And first, I just need to run a couple of Docker commands to get a database running on my laptop. And the fact that it's just a few commands is kind of a testament to the fact that there's not much that you have to do. Pretty much the hardest thing is actually setting up the database to sync it with. Here's our create table commands. You can see we have ID, Stripe ID, product name, which you might be sharp enough to realize we are not naming it name, it's product's name. And then last but not least, we need to start up Remix. Okay. So now we will go into our database querying program and just show an empty table. I need some waiting music. Somebody drop me a beat. Yeah, thank you. So now the key here, I'm just trying to show you, I'm selecting star from products, and we have nothing. We have an empty products table. But we have Remix running. And so if I open up Safari, because I'm an Apple fanboy and I refuse to use Chrome, we can go to my products catalog and let's create a product. We'll call it Stripe Dublin Ticket, because the meetup is so successful, they have to start charging for it. We're gonna make it $5. It's a very confused product. No one here has dollars. And there you go. In our Stripe account, we now have Stripe Dublin Ticket. And if we go back to our database and select, it has replicated there. Let's just do a few more commands just to show what it can do. It doesn't just create things, it can update, it can delete. So if I click in here and say I wanted to change the price of something, before, if I wanted to change it in my database and in the app, I'd have to change it in 2 different places. But let's just change down to $2. Go back down to the database, and if I query it again, sometimes it takes a second, there you go. The price has changed to 200. And the sync can also happen in the other direction. If we wanted to update the product name to new product name, we can update it in our database, and that should replicate back to our Stripe account. So there you go. It does, in fact, do the job. Now, Remix is actually a totally new product, and syncing Postgres in Stripe is the first use case, but it's just the start. What I imagine is lots of different data systems that can bring in and transform data into these so-called canonical data models, and then send them back out in real time. Because it's a new tool, we're actively seeking early adopters. So if you have any interest or any project that you think Remix would be a good fit for, please contact me. Actually, we're looking for people to say, hey, we want to test this against the real world. Basically, I'm looking for people to beat it up, to find the rough edges. And we are offering free support and the ability to influence the roadmap. So if right now, you want to sync data to your Stripe account, but you use SQL Server or MySQL instead of Postgres, that's totally something that I'd love to hear about. And the product roadmap is currently available, as well as more information about the product at sqlpipe.com/products/remix. And if you want to contact me, here's my contact information. I'm Cal Mitchell. My LinkedIn URL, my email, QR code that goes to my LinkedIn, etc. And the general contact form for my website does eventually make it to me as well. So I will open it up for questions, but I'll just leave that up for a second in case you want to take a picture or something. Does anyone have any questions?
Let me give you a mic here. Who was the question?
Thank you very much. So it looks like everything is based on files, on name of the file. Like you're providing the directory and models basically based on the name.
That's correct. You define the logic that transforms incoming data using YAML files. I call them remix files, and they're great to store in source control or whatever, and it's a really great way to track how your schema is evolving over time. It just doesn't come across very well in a presentation, so I didn't show those files. But that's a great point. It's YAML files.
Right. So I guess the continuation of that, were you thinking about extending it, actually making it into like, I don't know, proper schema and mapping between those? Not sure how to put it. Basically not file-based, but rather like, I don't know, the single file, let's say.
So the UX of the program is, I think, the most important part of this tool. There are lots of things that move data around. Kafka already exists. What I was trying to do is find the simplest way to declaratively make data sync between two systems. And being declarative is important versus imperative for all my nerds out there in this case, because you can really easily keep something that's declarative in source control and track it over time. So, YAML files for the remix logic, and then JSON schema for the schemas themselves. That's just the architecture that I arrived at. And the actual structure is you create a remix file with a receive mixer and a push mixer for each system. And that controls, here I'll just flip back a couple. So the receive mixer is what defines this logic. So you basically have to tell it that, hey, when Stripe sends me a price, you need to alter unit amount to price, and you need to alter product to Stripe ID. And you need to do that for Stripe, and you need to do that for Postgres. You need to do that for every system that you want to push and pull from. Does that answer your question?
Yes. Okay, thank you.
I appreciate the data sync, right? What I'm looking at is, for example, let's take the scenario for prime day scale, right? Where you have a product A, which is sold at about €5, and in a prime day sale for about 2 days, they sell it at €4, and after the 2-day sale, I want to bump it back to €5. Or, for example, if you take a cloud pipeline, right? I'm running a 8-core 16 gig VM today, and suddenly prime day sale comes in. I have to bump up my traffic for a couple of, instead of running 8 VMs, I'm running 10 VMs. I bump it up, and then I come back, right? So in both these cases, the attributes of the product per se does not change, but the values of these attributes are fluctuating, but not standard, right?
So what would be an example of a field that changes there,
the
that
price,
changes
for
value?
example.
So anytime you change a product in price, a price in Stripe, you get a webhook.
Right.
Yeah. That's how it,
Yeah.
basically it listens for those webhooks. It doesn't have to go get them.
Right. So, the point I'm trying to make is, for example, during the Prime Day sale, 4 to 2 days, I won't offer a 20% discount.
Mhm.
But post the Prime Day sale, I wanted to go back to the original price,
Okay.
right? And in this scenario, on day 0, my price goes down by 20%, and day 2 it goes back to, the normal price, which is 0%. From -20, it goes back to 0. But from remix, the attribute change would attribute and affect all the products, versus when I want to account for the sales, for the sales that happened in the 2 days of the Prime Day, I want to count it at a -20% cost, versus when I count it post Prime Days, I'm accounted at a 0% cost and not at a -20% cost. For example.
I'm just having trouble understanding exactly what it is from an IO perspective. You're saying that in Stripe you're offering a 20% discount on all of your products for some time limited
Right.
period.
Right.
And I'm not super familiar with the Stripe dashboard actually. So do you go in and do you click, put this on sale for 20% for 2 days, or do you actually have to key it in manually?
I'm also not so sure. I haven't used Stripe in a
Well,
long
so
time.
what I can tell you is that as long as Stripe sends you a webhook, which it does when anything changes, then Remix will apply that. And whether you did that to all of your products, it will apply it to all of your products in your database. And whenever it's changed back in Stripe, it will do that as well.
And the question that I'm asking is the fact that it's changing all the products. Because when I'm doing my financial accountants, for example, in this case, I'm accounting for more spends than actually that was spent. Right?
Well, if you separated your price and products as Stripe has, then that wouldn't be a problem because your sale in your database probably has a price ID, not a price. So the way that Stripe does it is like a transaction has a foreign key to the price that it was sold at, and you actually cannot delete a price object in Stripe. So that might help you with your accounting after the fact.
So what you sync is to the price ID and not to the price in itself.
Well, it's totally up to you how you set up your remix files. Yeah, it could support that use case, it's just that you would have to define that, and it's very flexible in that way.
Thanks, Kyle, for the talk. In terms of when you're talking about syncing petabytes of data, because I work in bank and sometimes the data servers can be located in different locations. So
Yeah.
when you commit, I think if we talk from Stripe example, your data center may be based in Rutherford and I'm hosting remix in some APAC data servers or something. So how does the syncing work? Like, is it always real time, or do you feel like, lagging if I want to create like another prod replica of the whole database and I'm not finishing the full commits, on the database? So will it be reflecting on Stripe accounts as well, real time, or how does that thing work?
So what it does is it listens in real time, but it doesn't push right away. And you can actually set rate limits for how often it takes things out of the queue. So let's say you have some data warehouse that you actually do not want to send, 10 requests a second to. Maybe you want to run it every 10 minutes or something like that. What it's going to do is it's going to listen to everything, and then all of the objects that validate against your canonical data models, it puts them in the queue. And then according to that rate limit, which might be once every 10 minutes, so you can control like that latency. Does that answer your question?
So you're suggesting like you have to do like prompt scheduling, in the queue, like how much you want to push and how much you want to kind of
That's right. Every single system that you define a remix file for,
yeah.
you define how often that system should be pushed to. How often that system should scan the queue looking for objects that need to be pushed to it, and then actually executing that push.
Okay, so it's like similar to Kafka, like the broker and worker models.
Yeah, you can think of it like a batteries included Kafka. So I would actually say that Remix, companies might find it interesting if they already have Kafka, but it's more interesting to companies that don't already have Kafka and they just want to solve some particular use case. So let's say you want to sync data between Stripe and Postgres, but you don't want to learn to use Debezium, Kafka, schema registry, and then write custom upsert code, whatever. This is one tool that does that instead of learning a ton of different Kafka concepts.
Thanks.
Sure, thank you for the question.
Al, thank you very much.
Thanks everybody.
Al.